Hello, Geometry Honors. I hope your week is off to a good start. I hope yesterday was great and that today is going to go even better. This is going to be one of the most important lessons that we ever do because it's the foundation for Chapter 3, 4, 5, lots of things that we're going to do. So, congratulations. You've survived Chapters 1 and 2 and you're still in the class. Here are some shortcuts that you are going to start doing in your proofs. First one, it's already highlighted, no more assuming straight angles. You'll just go straight to saying straight angles are congruent or sum of two angles is straight angle, then they're sup. These two bullets you've already been doing since day one. Next is your 1.4 theorem, no more if-then statement, just perp, seg, form, right angles, done, beautiful. Sorry, that was 2.1 definition. Then your 1.4 theorems. We used to say if two angles are right angles, then they are congruent. We don't have time for that anymore. Just go right to right angles are congruent. And then from lesson 1.5, if you're using bisectors and trisectors and midpoints, we'll stop doing the if-then for that. We'll still use the if-then if it's the very last reason in a proof. Actually, this one will stay green also because that's all 1.5. So you know what, let's just, not that this really matters, no one's judging. There we go. All right, so if some of those are unclear, you'll see them in action now and every day for the next couple chapters. All right, so here's a couple things that you saw in lesson 3.1. You had a postulate that says any segment or angle is congruent to itself. You know that better as the reflexive property. And so if it seemed weird or useless yesterday, I hope it makes more sense today. So this current picture already has lots of tick marks on it, and we're going to add one more set right here and say that segment MT is congruent to segment MT by reflexive property. So then there's three sets of congruent sides, three sets of congruent angles. Those two triangles are congruent, and super duper important both for chapters 3, 4, 5, 8, 9, lots and lots of places. Line up the corresponding vertices. So now it does not matter how you name the first triangle. If you want the first triangle to say HMT, great. Or MTH, perfect. HTM, whatever you like best. So I'm just going to go with HMT, I think. What matters now is that when I make my second triangle statement, the letters must line up correctly. So H corresponds to A. Look at those tick marks. M lines up with M, and then the T lines up with the T. So that's one way to do it. All right. So as of 3.1, it took 6 statements, 3 sets of sides and 3 sets of angles to make triangles congruent. Well, here's the good news, everybody. Some old dead people found some shortcuts, and so we're going to take advantage of those shortcuts. So we don't need to get 6 things. We only need 3 things. We only need 3 things to make triangles congruent. So here we go. We're going to use some abbreviations. We'll have some words. We'll make some pictures. Everyone's going to be really happy about it. So the first one will be known as S, which stands for side, side, side. So 3 sides of one triangle congruent to 3 sides of the other triangle. That's side, side, side. It's a great one. Next one is SAS, side, angle, side. So it doesn't matter where we start, but we'll pick that side. We'll pick that side. Now, notice on the letters, the A is between the S's. I'm just going to zoom in here just to make sure I do it cleanly, nicely. There we go. So the angle has to be between the 2 sides. There's even a word for it. It's called included. Everybody wants to be included. All right, there we go. Otherwise, we get sad. So it has to be the included one. Otherwise, the triangles might not be congruent. All right. Remember, if I'm going too fast, just tell me to slow down or just pause the video. There you go. All right, and we have A. A stands for angle, side, angle. So it doesn't matter which one you pick first. I'll just go ahead and up there. There's 1 set of angles. There's 2 sets of angles. And then it has to be the side that's in between those angles. So again, there's that word included. There we go. That's A, S-A. Now, I was going to say to make a long story short, but I'm probably better at making a short story long. So that's everything you were supposed to learn today. Does that mean we can pack it up and go home? Try it and see what happens. I don't know. So there's that's all lesson 3.2. So for years and years and years, that's all we did. But then for some reason, I don't know who got crazy. One of us got crazy. And we decided, you know what? We're going to go to lesson 7.2 because there is a fourth way. So let's go nuts and throw it in there. I guess let's see. Let's get some blue. And so this one is called A. S, angle side. So check this one out. There's one set of angles. There's two sets of angles. Now, go ahead and pick a set of sides that's not between the angles. So I'll give you a choice. Do you like those? Excellent. That's great. Or do you like those? Fantastic. You're right. So take your pick. Pick either one of those and make sure everything still lines up. And those triangles are guaranteed to be congruent, and that's called angle side. So that's all we're doing for now. Now, I'm probably not supposed to say this out loud, but you know I can't stop myself. There's going to be a fifth and final way that will still be coming down the line. But right now, for the most of Chapter 3, we have 4 ways to make triangles congruent. And they all involve 3 things. Now, if your brain works very logically, you might be looking at this list and saying, but there's other combinations of A's and S's that I don't see there. You're right. There's some that don't work. So, angle will not give you congruent triangles. They might be, it'll actually come back in Chapter 8. They'll be similar triangles, but not congruent. Excuse me. And then the one that some people are thinking of right now, you don't see SSA, and I know somebody really wanted me to write this, but you know I wouldn't do that. That'd just be inappropriate, so we're not going to do that. So we'll call it SSA, and that one does not work. When I'm back in front of you in real life as a person, I will show you a visual to show why SSA does not work. So there we go, though. So don't use AAA, don't use SSA, ever. All right, so now what I'm going to suggest to everybody, pause this video and go ahead and do your given as shown given and just go ahead and duplicate it. So we're going to save a few seconds there to our day. So go ahead and do that. And then it's time to get real. All right, so pause the video, set those up, come back when you're ready. Okay, hopefully you're back. I'm back. So this one's wild, W-I-L-D. All right, so we're trying to get these 2 triangles congruent. Now here's the really cool thing. For today and tomorrow, you'll be given the letters in the correct order. After that, it's up to you. All the pressure is on you to make a perfect statement. It'll be easy, don't worry. But you got to use your brain a little bit. All right, so we need 3 things. I'm looking to put some tick marks, but there's no congruence in the givens, so it means we'll just have to do a little bit of work. So in any order you want to, I'll just go in order. ID bisects angle WIL. I'm going to put some tick marks, and then I'm going to make this statement. Angle WID, the width, is congruent to angle LID, the lid. Oh, the width and the lid is probably part of a Dr. Seuss book. And now here we go. For the first time ever, we'll just say angle bisector divides angle into 2 congruent angles. So with that one, you know, we want to shorten things up for you guys because the proofs are going to get longer. So we will skip that as a if-then statement. All right, gorgeous. So that is 1 congruent statement in our triangles. And let's switch colors. And segment ID perpendicular to segment WL. You know what's going to happen. Angle IDW. Angle IDL are right angles. And so here's another abbreviation. Perp, seg, form, angles. There we go. We have 2 right angles. And I'm going to go ahead and keep it the same color because then we already have the tick mark on the picture. Angle IDW is congruent to angle IDL. And so here we go again. No more if then. We're just going to say right angles are congruent. That's our theorem from 1.4. So we have red angles, we have purple angles. We need one more congruence. Here it is. I hope you're ready for it. Segment ID is congruent to segment ID by the reflexive property. So you can just write ref, because some people will spell it wrong. So if you just write ref, you'll never spell it wrong, I hope. So we'll just write reflexive property. And so we have red angles, green sides, purple angles, ASA. You can already see it happening. I don't know what color to use. All right, we're going black. It's happening. 6 steps. That's fantastic. So triangle width is congruent to triangle lid. And then we will say angle, side, angle. There it is. 2 congruent triangles. And stay in school, and in future lessons, we will go beyond congruent triangles and do a bunch of other geometry. And I hope you'll love it. All right. So I forgot to set a stopwatch to see how long this video is, but let's just do number 2, and then we will pause it. Or yeah, that's what we'll do. All right. Hope you're still awake. Hopefully this feels good. Now, here's the thing I was supposed to say at some point. I'll say it now. If you felt like everything we did in chapter 1 and 2 with proofs was really confusing and you didn't see the purpose, hopefully this is right now, this moment, this is your time to see the purpose, because we are getting congruent segments, congruent angles, and the right combination of that will make congruent triangles. All right, let's see what's happening next. Here we go. All right, nothing, no cute words, just letters. All right, let's see if we can label anything. ADAE. Oh man, I don't like to label that one because it's really hard to tell what we're doing. So I might do this. That might be the best way I can label that one. AFAG. All right. CDBE. Okay. And you see a double bisector. That's a hint. Your brain is already thinking one of 2 things. What's it going to be? Stay tuned. Let's find out. Now, remember, this is absolutely not cheating. It's super smart and strategic. So take a peek. Even grab your highlighter. Our goal is to get this triangle right here. Uh-oh, my pen just got weird. Sorry. Oh, it's still weird. That's disappointing. We're trying to get that triangle in yellow, congruent to... Jump, jump. Oh, it did it again. Oops, it did it again. Come on, don't let me sing, guys. That's not good. So we're trying to get those 2 overlapping triangles congruent. So look at your tick marks really quickly. Right now, we only have 1 congruence. All right, AD is part of triangle ABD, and the AE that we have is part of triangle ACE. So we have 1 congruence. We need 2 more. So buckle up. It's going to be fun. We're going to find them. Oh, except now I can't undo this darn highlighter. Oh, boy, oh, boy. All right. So the order of these next 2 steps doesn't matter. I'm going to go with what I know your brain does more easily. And so we're going to look down here at the bottom. We're going to take all this empty space right here. We're going to add it to CD. We're going to add it to EB. So then we're going to get rump and rump. So we're going to get a little CE congruent to DB. Before I say it, I want you to think of the property that you're thinking of. That doesn't make a lot of sense. So what property do you think it's going to be? And I hope you told yourself, add prop, baby. There you go. Beautiful. So that's a congruent statement on the triangles. And a little bit ago, we foreshadowed a double bisect. So your brain's already thinking, is it going to be multiply or divide? And then now when you look at your picture, tick marks, you look at the given statements, you have these 2 little baby segments up here, but they're both half of something. So you know what's happening next. You're going to multiply. You're going to double those bad boys. So AC is congruent to AB by your mult prop. Oh, yeah. So now we have the blue sides. We have the red sides. We have the green sides. Maybe yours are different colors, so maybe that was a stupid way to say it. I don't know. And so now I just said sides 3 times, so you know what's happening. That's side, side, side. So there's our triangles. Triangle ACE is congruent to triangle ABD. All right, you've learned 4 ways to make triangles congruent. We're going to be doing that every day for only a couple months. No big deal. So now I'm going to encourage you to Well, actually, never mind. This video is about to end. I was going to say pause it. But this video is going to end soon, and I want you to now actually talk to the beautiful humans on your team and try the next 3 proofs with whatever time you have left. But if you need any help on those proofs, then you can tune in to the next exciting video. Maybe if these videos are so good, I'll start getting paid. What do you think? All right, let's get some subscribers here. I don't know. What do they say? Like and subscribe. Smash the subscribe button. I don't even know, guys. I don't post anything. So anyway, I miss you so much. I can't wait to be back in front of you telling my horrible jokes. So, all right, I got to stop this video. Talk to you soon. Bye.